Hey everyone, it's Jim
And Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 254, we're going to talk a little bit about analyzing preamp tubes. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Well, for a while now, we've been doing tube labs that are focused on preamp tubes. And for good reason. Preamp tubes can make or break a system. The reason for this is they are responsible for all of the voltage gain in the system, at least in an all-tube system. And that's often where the magic happens, or the shit gets injected. Now, if you've got a blended system where you've got some solid state and some tubes, hopefully the designer showed some brains and put all of the voltage gain under the tube side and left the solid state for, I don't know, something else useless. But
power supplies.
Yeah, which is actually a very good place to put solid state technology, particularly the diodes. Anyways, I digress. Now, in the past, we've done critical listening notes and put up live captures recorded directly off various MTA kit preamps. But can we bench test a preamp tube and get a meaningful idea of the performance? 3 question marks. Well, we could show its exact operating point. But what would that tell us, other than the designer knew what they were doing and the operating point is centered? What if we could play a specific frequency and make a detailed plot of its performance, including all of the noise and harmonics? That might tell us something, or a bunch of somethings that are useful. What I just said describes something called a full audio band frequency sweep, or just sweep for short. Now, I've noticed lately that quite a few equipment reviewers like to sweep at 1 kilohertz and give an analysis at 1 kilohertz. And there is nothing wrong with that. 1 kilohertz is basically in the middle of the audio frequency band. And I think you could call it, let's say, the top of the mid-range, something like that. But I'm not really sure why they only do 1 kilohertz. Why not do a full frequency sweep? And the reason why I'm wondering is, sure, a lot of testing data is done at 1 kilohertz. That's sort of the nominal. If you're going to pick a frequency, that's the one everybody picks. It's in the center.
You can't show every hertz and its distortion numbers and everything. It's just not realistic. You either have to pick one or a small series of them like we tend to do.
Yeah, so what we normally do in our specifications sheet for all of our kit preamps is that we normally pick a typical low frequency, a mid-range like a 1 kilohertz, and we'll pick a high frequency often. It depends on what the preamp or what the kit is, of course. But in my opinion, doing the full sweep from 10 hertz all the way up to 20 kilohertz, now that tells a lot. Now, we use this method, the full frequency method, for analyzing the performance of our kit amps during development, and it's an integral part of what becomes the specifications. Now, let's see if it can also be used to discern the differences between various preamp tubes. And now we're getting to the meat of the episode.
Okay, so we've got some tubes laid out here, and each one of these we've actually swept on 2 different preamps. We did the 6SN7s. We have a beautiful GTA Sylvania straight plate, and the Tung-Sol GTB Tallboy. We did both of these on my noise testing preamp that I use just about every day at both a correct operating point, and in the case of the Tung-Sol, we did one with it at a really wrong operating point to show you what happens. And the 6N1P and the 6N6P, well, 6N6P is getting used in everything, but the 6N1P we specifically swept on our new balanced prototype preamp, so we can compare it to the 6SN7s.
Yeah. Now on the balanced preamp, we swept on the single-ended RCA side.
Yeah, so that's going through a phase splitter, and then it's coming out on just one phase. We don't have any sweeps yet of the full, both phases coming off of one channel.
Yeah, and the cathode follower that we used with all three of these preamp tubes was the 6N6P.
Mm-hmm. And basically the exact same operating point on all of them too. So that's the same across all of them.
Okay, well, let's pull up the first of the sweeps, and we'll talk a little bit in detail about what you're actually looking at, and then we'll go and we'll look at the sweeps for each and every one of these tubes. Okay, through the magic of editing, Charles has got the Sylvania GTA straight plate plot up.
And actually, I should make a quick mention of what we're using here for software. So this is all plotted on REW. It's short for Room EQ Wizard. It's a common tool used for sweeping preamps and for sweeping speakers, checking room setups, and everything like that. So what you can see here at the very top, we have our fundamental. This is our signal, and it's sitting right at the 0 dB line, and we equalize everything to that so that it's easier to plot how far below it all of our distortion numbers are.
So everything is essentially relative to the fundamental, right?
Yeah.
Okay.
Okay, so down below this whole graph, we have our legend, and this is telling us what our fundamental is, which is 0 dB. Our second, third, and fourth harmonics, which are the next harmonics after that. It can go all the way down to the eighth, but they don't really tell us a whole lot of information.
Yeah, so we've chosen not to plot them, otherwise the graph gets really confusing.
Even more so than it already is.
Now, if we were doing deep analysis in particular if we had a problem, we didn't know where it was hiding, we might actually start isolating the harmonics to look at them individually. Mm-hmm. But right now you're looking at a screen capture, so we can't start manipulating for you.
Yeah.
And one thing we should mention is the percentages that you're seeing at the bottom are all at 1 kilohertz.
Yeah, so just like we were talking about before, you have to choose a point to take these numbers off of, and we're going to choose 1 kilohertz, but you can look at any of the frequencies yourself if you like, and figure it out. It's pretty easy. So we've also got our THD, which is our total harmonic distortion, and this is just the top level of all the harmonics, no matter where they are at that point.
Yeah, whether they're good or bad, and we'll talk a bit about the good harmonics as we move along.
And then we have the noise floor, which is pretty self-explanatory here. So this is the GTA straight plate, and this was done through the prototype testing preamp. Pretty simple, no-frill circuit that I use every day, and as you can see, it's pretty clean, although we do have some noise spikes at points like 60 hertz and 120 hertz.
And then multiples thereof. Mm-hmm. Those are essentially reflections or echoes of the fundamental noise source, and that's very, very common in circuits. And obviously you want to have your spikes as low as possible, but it is what it is.
But if you look at it in the percentage sense, it's actually very, very low. So the total harmonic distortion is 0.021%, at least at 1 kilohertz.
Yeah, and in tube gear, if you can get down to, let's say, 0.1%, at that point, most people call it good. So 0.021% is really quite low.
Especially for something that's really not meant to be consumer gear. It has an open bottom on it. It's a bit of a snake of wires inside. So I'm fine with that.
Yeah. Now, to get you into sort of perspective, what does, on the left side, you'll see 0 to minus 100. Well, that's dB. And dB is not linear. So it is an exponential number.
Logarithmic scale, I believe.
Logarithmic scale, sorry. And minus 60 dB, which is cutting right through that big peak at 120 hertz. Minus 60 dB is basically quiet. If you can get a piece of gear down to minus 60 dB, you're not going to hear any noise off of it, even at louder volumes. I mean, eventually, if you turn a powerful system all the way up, yeah, you're going to hear some white noise off the system.
Mm-hmm. Every 3 dB of change is a halving or a doubling of the equivalent loudness of the audio. So being minus 50, minus 60 down there, that's very low.
So that just gives you a sort of perspective. Otherwise, you might look at all those squiggles and say, holy God, that's noisy. Well, in a sense it is, but if you put that noise into a relative perspective, it's not. And if we sweep any piece of audio gear, whether it's home audio gear or pro audio gear, we're going to see something like that. In pro audio gear, in which noise is really critical, it might actually be a little bit lower than that, or it might not. So what have you got up next, Charles?
Okay, well, next we're going to compare the GTA straight plate to a Tung-Sol GTB. And the reason why we did this is because the GTA is often considered to be a very warm tube, while the GTB Tung-Sol is often considered to be a very detailed and less warm tube. So
I wouldn't say less warm, slightly less warm.
Yeah.
Would be a good description.
Yeah, I mean, the 6SN7s in general as a type tend to be fairly warm tubes, so let's see how this actually compares, sort of apples to apples here. Same preamp and same operating point.
Okay, so the total harmonic distortion is exactly the same. Mm-hmm. The noise floor is a little bit lower at 0.008 than the Sylvania. Mm-hmm. Second harmonic distortion is almost exactly the same.
But it's slightly lower.
Slightly lower, but...
and same with the third.
Yeah, but the difference is almost negligible.
Yeah.
Okay, well, what's next, Charles?
Okay, well, now we've got something fun here. What happens if you don't bias your preamp tube correctly? Well, this is what we just did. So we actually my preamp, my testing preamp, you can change the load resistor and the cathode bias resistors on it with just a couple of rotary switches.
And the purpose of that, of course, is so that Charles can test numerous different types of tubes at a correct centered operating point.
Yeah, where they're expected to run.
Now, you might think that this is a complete waste of time, and it would be if designers of equipment, particularly modern designers, actually knew what they were doing. The problem is a lot of them have no clue, and we can tell almost instantly when just glancing at the description of a piece of gear or the specifications that they are flubbing it, basically.
Yeah. So take a look at this. So we have a improperly loaded 6SN7. It's the same Tung-Sol we were just looking at. And what has happened with our total harmonic distortion? Well, it's gone from 0.021% all the way up to 0.324.
So it's almost 10 times. It's more than
10 times.
More than 10 times.
The amount of harmonic distortion, and almost all of that is in the second harmonic, although we do see a chunk of third harmonic coming up there as well. And if you look below the fundamental and below all the squiggles of the noise floor, there's your second harmonic, really elevated, up at minus 50 dB approximately.
Yeah. So
this is what happens whenever you have an improperly biased tube. It tends to sound very warm, verging on muddy and distorted, and this is not where you want it to be sitting. You want it to be in the middle of its operating range.
Yeah, and what does all that distortion mean for clarity?
Oh, it disappears completely.
Yeah.
Yeah. Too much second harmonic, like we love second harmonic, but you need just a little bit of it to really help liven up the sound. Anything more than a little bit and it just muddies it, you lose detail, you lose clarity, and it stops sounding good.
Yeah, and in a couple of screens we'll actually show you what our new balanced testing preamp looks like as far as second harmonic, and it's quite a revelation. But first, we're going to drop in and look at the Photon 6N8S, which is the equivalent to the 6SN7 GTA or GTB.
Mm-hmm, but built very similarly to the famous Sylvania Bad Boy, and we think it has a lot of the same sound to it. So let's go take a look. Okay. So here's the Photon sweep. It's very similar to the other ones. We've got fairly low distortion across the board, slightly higher total harmonics at 0.023.
But almost the same basically as our Sylvania and Tung-Sols in the correct operating point. And noise floor is very, very similar. The second harmonic, though, came up quite a bit. So the Sylvania and the Tung-Sols were at 0.009 and 0.008 respectively. And the Photon is at 0.013, which is a fairly significant increase in the seconds.
Yeah, I mean, these are all very low percentage numbers, but if you're comparing 0.013 to 0.009, that's, it's 0.004 of a difference.
Yep, and the third stayed roughly the same.
So it really shows how we get more of that second harmonic in there. You get a bit more of a warmer sound, and you don't get really any harshness being added in from that third harmonic, which the odd harmonics, I don't think we mentioned this earlier, tend to add a bit of a sharp harshness to things, and you don't want them.
Yeah, and what most people don't realize is that in solid state circuits, the third tends to be dominant, and in tube circuits, the second tends to be dominant. Now that's a very general rule, and you would have to take it on a circuit by circuit preamp or amplifier by amplifier basis. Mm-hmm. Okay, so up last is really quite interesting.
Yeah, so this is the first time that we've actually swept our new balanced preamp. And swept it using RVW. We've actually done some manual sweeps using a different method. But this is really interesting. And what we're seeing here is an elevated second harmonic. And we've been commenting for the last couple of weeks about how good this preamp sounds, how it seems to liven up everything that we're throwing at it. And take a look at this. We've got a higher total harmonic distortion, which isn't that surprising. We've gone from 0.021 to 0.077. That's, a little over 3 times. We've got roughly the same noise floor. It's very low.
Yeah, let's go back to the total harmonic distortion at 0.077. So let's call it 0.08, rounded up. That's still not terrible. In fact, I would say it's still within the bounds of totally acceptable.
It's less than 0.1%.
Yeah. What about the second, though?
Well, there we've gone way up. So we've gone from the highest of the 6SN7s that we just tested, which was the Photon at 0.013, all the way up to 0.074. So that's a huge change in how much harmonic distortion we have.
Yeah.
It's still a very tiny portion of the overall signal, but it's way higher than the other 6SN7 types, which is a bit surprising to us because we've always considered the 6SN7 to be a very warm preamp tube. But maybe something with our circuit and the 6N1P has really brought out something special here.
Now, you might have noticed that the second harmonic at 0.074% is very close to the THD of 0.077%, and that is true. They tend to be very much correlated, particularly if the second is elevated. So a big portion of the total harmonic distortion is the second.
Yeah.
So if we were to pull the second out of the data, you would find that the THD actually is very low. And that's why when you're analyzing specifications and data for any piece of audio gear, having a good understanding of what you're looking at and hopefully the manufacturers actually portray things in a way in which you can analyze them and compare them and understand them. That's not very common, unfortunately. Would help you a lot. So if you were to just look at the new balanced preamp kit and say, wow, the THD on that kit's way up at 0.077%, and walk away from it based on that one specification. And in the 70s, that's the 1970s, that's what we used to do. And we were idiots. We were so wrapped up in the idea that the specifications were the beginning and the end of what a piece of gear sounded like, that we ended up with specification wars. We ended up with watt wars.
And it really hasn't ended. Everybody is always trying to get the best frequency response way up into the tens and hundreds of kilohertz range, way out of human hearing ranges. And
there's no common sense to that. Now, let's look at that third harmonic, which is down at 0.009%. Well, it's 86%, but I've rounded it up. that has actually stayed very low. So the second came up and the third stayed down. And is that good news? Yeah, absolutely. We don't want the third to come up. So in a way, we got a very good result with the second, and a very good result with the discordant third.
Mm-hmm.
And that would explain why in critical listening tests, the new balanced preamp just floored us. I mean, everything we put in there, whether we put in a true balance signal off of our Denafrips Pontus 14th, is it? 14th DAC, or we put in an unbalanced signal off of our phono preamp kit.
It's all sounded great.
It all sounded great. And
it really doesn't take that much added second harmonic on here to affect that. I mean, if you're looking at the testing preamp, we're talking less than 0.01%. If you're looking at the new preamp, we're at less than 0.1%. It's really tiny amounts, and it makes a huge difference for how it sounds.
Now, what is all of this telling us? Well, first of all, it tells us that the detailed sweeps that are analyzed with some knowledge can make a better understanding of what you're hearing. But when you're doing critical listening, that is the final arbiter. So if we were to, let's say, go at this the other way around and design the new balanced preamp, which will be a kit eventually. It's in the works. We actually have a really huge week coming up in a week over at Melatonin Amps. But once that big week, well, it's probably going to end up being a big month. Mm-hmm. But once that's done, we'll be putting into development the production side of the new balanced preamp. But if we had worked on the bench testing first and not done any critical listening, we might have run away from that total harmonic distortion number and never actually listened to it. And that would have been the biggest tragedy of our careers as designers. But we don't do it that way. No. We get a circuit working. We test to make sure that the basics are there, that the operating point that we've designed, that Charles has
plotted, it's where we want it to be, that our power supply is stable.
Yeah. I mean, we don't want the operating point to be precisely. It never is. But we want it to be very close to what we've designed. Mm-hmm. We want to check to make sure that the power supply is working properly, the voltages are all stable. And then what do we do next? Once we know it's safe to plug a speaker into it,
we go and listen to it.
And do we take notes initially? No. All we want to do is listen. We throw some test tracks at it. Then later on, we start to take some notes. And then we bring it back to the bench for more in-depth testing. And we knew that we were going to see probably some elevated second harmonic because we could hear it. But we weren't hearing any really nasties in the third and fifth and onwards. So we knew that there wasn't a lot of evil distortion coming out of the preamp. In fact, there was nothing but to-be goodness.
Yeah, and we also heard that it had very good low-end frequency response, and we were seeing that in our sweeps earlier today. That's on a different plot than what we're showing you right now, but it's performing very well.
And before we go, we should mention what you're looking at is essentially the distortion plot. That's what we were putting up. There is another sweep that we can display.
It's basically just a flat line with a little curve on each end. So it's not that interesting.
It's not that interesting, but it shows the frequency response, which is really important to make sure that we're not rolling off the bottom end, that we don't have any dips or dives. And in fact, actually, before we go, why don't we put one more plot up? Just so that we can show everybody what we normally start off with. Okay, so we've got the prototype balanced preamps frequency sweep up, and as you can see, we actually kept the cursor right at the 1 dB down point, which is about 11 hertz. So the low end performance is extremely good. When you look at the curve going down on your left-hand side, you might think, oh, the bass performance is the shits. But what we've done is we have actually shown it in a very high resolution. So you can see in a very detailed way. Now, what manufacturers do, and this is particularly bad for headphone and speaker manufacturers, is they will actually zoom out instead of zooming in, so that you actually can't see the badness, or it's really tough to discern what it is. And when they do that, and you see that they have not zoomed in so that the resolution is really low, that should start sending, warning bells going, because they're trying to show you the plot, but they're also trying to hide what the plot's showing. So, and we often laugh at that. Even big manufacturers who should know better try that trick. So now it could be marketing departments that get involved. Can't we make that plot look better?
Just a little flatter.
Now at the other end, in the treble, way up around 20 kilohertz, you can see the preamp's almost dead flat all the way until about 10 kilohertz, and there's a very small roll off heading to 20 kilohertz. So the frequency response is essentially flat, almost in the entire frequency band. So that performance is absolutely excellent, and I would be really happy if all audio gear performed that well. But as you can see, it's as boring as all heck, so I don't think we should spend any more time on that.
Yeah, actually, let's go take a look at some tubes that came in. That's a bit more fun.
Well, we were just actually talking about the Photon and looking at how it performs as a preamp tube. And it's of all of the later production 6SN7s, well, I don't even know if you can call it later production. I would say of all the Soviet production equivalents to the 6SN7 GTA/GTB, the Photons are the tube that we chose to specialize in because it's simply the best sounding of the lot. There is a metal-based melts that we used to specialize in, and we handled hundreds of them, but they're essentially extinct and have been for a number of years.
And unlike the Photons, they have a serious noise problem. A lot of melt tubes do.
Well, what's essentially left available for sale are the rejects.
Yeah.
And in fact, when we were buying large lots of them and had to deal with our wholesaler for refunds for defective tubes, they didn't want them thrown out. They wanted them returned.
Yeah.
And you know why? Yeah.
Yeah, they were going to resell them. Yeah.
Yeah. So those tubes are still floating around out there. But the early Photon with that foil getter, this has got to be the best buy available in a vintage 6SN7 that you can find new old stock these days.
And it gets even better because we've actually gotten in some used ones too. We don't typically get in used tubes. We always try to find new old stock when we can, but we've gotten in a small batch of used ones that have tested out very well, that are all cleared, ready to go, and they actually look quite good. Many of them are probably very little used poles with some small cosmetic defects. You can see we've got a little bit of marking here on this guy.
Show off the other one. Its base is more typical for a Soviet-era tube that's been bouncing around. You can see
we've got some modeling on here.
A lot of Soviet-era tubes that were bulk stored were just basically chucked in a box.
Yeah.
Probably not a very good-looking box. And they bounced around and bounced around.
Had a leaky warehouse roof on top of them. Who knows? But we've cleaned them up. We've gotten rid of the bad ones. And these are probably the best-priced, least expensive 6SN7 that we have in the store right now. And we don't have a lot of them. I think maybe 8 pairs, I think.
So they're a bit of a bargain. Okay. Yeah. What else have you got, Charles?
Okay, well, we've continued to search for, or I should say Dad has continued to search for and find these wonderful Sylvania EL84s, also called the 6BQ5. And the Sylvania version of these tubes is one of the few that we specialize in, along with the Philips Muller tubes. And they are wonderful, they're sought after, they're reliable testing.
There's two versions of them, though, which is kind of odd. There's a black plate version and a gray plate version. And
I think there's also a lesser spotted matte black instead of this sort of shiny one as well, but we don't see very many of those.
so what we've done, the demand for the black plate is off the charts compared to the gray plate, so we specialize in the black plate version. And we have nice close matched quads in the store. They're not as expensive as the Mullard-Phillips version, which is good because those are rare and expensive tubes. And it's interesting, we're still able to find the Sylvania version. Even though we sell a lot of them, we've been able to keep bringing some in and matching up quads.
And importantly, these were made in the U.S. So for all of our U.S. customers out there, if you're worried about tariffs, these should have a minimal tariff applied to them, not the full amount if you're shipping them in. And we actually have some beautiful boxes for them too. And if you order a quad, we can even include a nice sleeve. And yeah, these are wonderful tubes. I think mostly a lot of guitar amps out there are running EL84s these days, but there must be some hi-fi systems too.
Well, there's actually a famous EL84 amp that it actually has a waiting list, and a lot of people who run that amp will also run it with the Sylvanias. And I think there's a forum that talks about the best tubes for it. I mean, if you're going to spend that kind of money on a power amp, you're definitely going to want to put the best tubes you can find in. Well, thanks for doing that, Charles. And if you've stayed all the way till the end, here's some discount codes to help you out. There's a secret code that's quite easy to catch, and a lot of people get it. Costs us a lot of money every year, and I'm really glad to see that. That means that it's either a returning customer or one of you out there viewing. And we can reach almost everybody around the world with flat rate $20 shipping. And if your order is $150 or more after discount, the shipping's on us, folks. This is Jim.
And Charles.
Signing off. Cheers, everyone.